In class, we just finished computing the autocorrelation function for our temperature data set, and I wanted to just do a few more things. We already started by computing the autocorrelation function at a lag of 1. Let's remember, here's the formula for that. Do we see this number 0.675 anywhere else in our spreadsheet that might be interesting? Oh, look, here it is as the slope of the trendline formula. And that's not a coincidence. If it's not a regressive order 1, the coefficient on our yesterday's y value will be the correlation, maybe some rounding, that we see in our autocorrelation function. So that's one slightly interesting thing. We also copied this and pasted it here to see that the correlation at lag 0 is exactly 1 because we can predict today perfectly given today. One thing we didn't try is taking our correlation at lag 1. We pasted it here, but we didn't go even farther. We didn't try a lag of -1, -2, -3, etc. So let's give that a try. So we can see that this has the original data, and then the sliding window is up by 1. Here the sliding window is up by 2 cells. So this is lag of -1, -2, -3. And what do we see about those numbers? We might notice that they are exactly equal to the lags at 1, 2, 3, etc. So the autocorrelation function is symmetric around lag 0, and that's why we just didn't bother computing these. Basically, if I can predict today from yesterday at a correlation of 0.67, then I can predict yesterday from today at a correlation of 0.67. Correlation is symmetric if you switch the two data sets you're talking about. So I'm going to erase what we had there because we don't really want to compute the lags at -1, -2, compute the autocorrelation at lag -1, -2, etc. For autocorrelation, later in this unit, we will want to compute the lags at negative values for something that's kind of like autocorrelation. In the next video, we'll play with the properties of AR1 processes.